I'm Anil Kumar. Final exams around the corner. Here is a review on rational functions. We'll consider all these topics in this particular video. The first one here is how to graph reciprocal of a function, and then we'll explore the rational function of the form ax plus b divided by cx plus d. Then we'll know all about asymptotes and take a few questions thereafter. One of these questions is find m and n for y equals to this. We'll write some values for X-Intercept or Y-Intercept or asymptotes, and you need to find m and n, right? So I've kept it open now. Then we'll graph the equation y equals to 2x plus 6 divided by x minus 2. We'll solve an equation 2x over x minus 12 equals to minus 2 over x plus 3. And then inequality 55 over x plus 16 greater than minus 6. And then we'll take up a very interesting question on writing equation from the given graph, right? So that is the kind of graph. So you can actually pause the video, copy these questions, solve, and then look into my suggestions. Now, in this particular page, let me use the space and provide you with reciprocal functions review, right? So let's begin with understanding what rational functions are. So when I say rational function r of x, it is a ratio of polynomials. Let's say px over q of x, where of course denominator is not equal to 0, right? So these are rational functions. Now, denominator is not equal to 0. That means we will have restrictions. Is that okay? So normally these restrictions are shown in the form of vertical asymptotes or holes in the graph of any rational function. Right? So that is kind of a short review of rational functions. And now let's take up reciprocal functions details. What is reciprocal function? So if I say, let me write down here, we'll discuss reciprocal function. Reciprocal means 1 over something, right? So if I say that g of x is equal to 1 over f of x, it really means that g of x is reciprocal of f of x, right? That is what it means. So if a rational function is being considered, the numerator is 1 or kind of a constant, you can say, right? And denominator is your function. Of course, it cannot be 0, right? So that's what it is. So what we will do here is we'll consider a few reciprocal functions and their graphs. So let me take quickly a few examples. So the best example is just a straight line. Okay, so if I take a straight line kind of like this, now what is the reciprocal of this line? I mean, the function which I've drawn here will be referred to as f of x. Is it okay? And what we are going to draw will be reciprocal of this, and we'll refer that as g of x. Is that clear? So 1 over 0 is not defined, so you'll get a vertical asymptote here. That is one thing. Second thing what you see is when the function is negative, reciprocal will be negative. So we'll have this part here in quadrant 3. As the function approaches a very large value, reciprocal will approach 0, and therefore we'll have something like this as part of our graph. Correct? So depending on the function, we can always calculate the y-intercept in this case. So what you see here is that we have one vertical asymptote and one horizontal asymptote. Correct? So that becomes your graph. Now this is the case when we have one X-intercept. If I have a function which is kind of like this, for example, right? So in that case, the graph should have two vertical asymptotes since there are two zeros, right? There are two zeros. So two vertical asymptotes. And the portion of the graph which is below the line, reciprocal will be negative, so it'll be kind of like this, right? So you get something like this as your graph. And let's say this value is a, then 1 over a is its reciprocal, so we get something like this, right? So what you see here again, that we have a horizontal asymptote, the x-axis, y equals to 0, and two vertical asymptotes. Perfect. Now it is not necessary that all the graphs will have these asymptotes, right? It is not necessary. For example, if I have a parabola which is kind of like this, in that case there are no x-intercepts, and since there are no x-intercepts, as we approach positive values very large, we approach horizontal asymptote. However, whenever on the negative side, so in this case the domain is all real numbers, the graph will be kind of like this. Do you see that? So what do you see in this particular case, that the domain is x belongs to real numbers. In this case, the domain is x belongs to real numbers. However, x is not equal to these two values, right? Let's say minus a and plus a. Let me write plus minus a. In this case, if I write this value as minus 1, then x is not equal to minus 1. So the reciprocal of a function may have restrictions. Most of the time it will have, but there are times when it may not have, like the graph which I'm going to discuss with you. Perfect. So these are all the reciprocal functions. Now I would like you to sketch reciprocal of another function. Let this be your test question, and I'll take up semicircle. Perfect. So here is a function for you. You have to sketch reciprocal of this function, which is a semicircle. So take your time, sketch this function. Let me give this value here as peak as, let me write this as 2. Okay. Now the answer should be something like this. We do have vertical asymptotes at these points. Perfect, because they are zeros, and then center part is positive, so we'll have all positive. Now if this is 2, reciprocal of 2 is half, right? So we expect something like this to be the graph of the function. Is it okay? So where this value here is going to be half, right? This value here will be half, correct? So that is how you will get your graph. Two vertical asymptotes at the edge, right? And the minimum value being at x equals to 0, y equals to half, right? So I hope that part is clear and you're clear about reciprocal functions. Let's now move and explore the functions of the type ax plus b over cx plus d. Right? Let us explore f of x equals to ax plus b divided by cx plus d in general, right? So in this kind of a function, how do we find vertical asymptote? To find vertical asymptote, equate denominator to 0, that is to say cx plus d equals to 0, and then solve for it. Cx equals to minus d, or x is equals to minus d over c, right? So that becomes your vertical asymptote. Perfect. Now how do you find horizontal asymptote? For horizontal asymptote, what we really do is we have ax plus b over cx plus d. We take x common, right? So if I take x common, I get a plus b over x, and here I get x common, I get c plus d over x, correct? Now what is horizontal asymptote? Horizontal asymptote is where the function approaches when x approaches positive infinity or when x approaches negative infinity. So if x is very large, in that case these two terms will be approaching 0, right? This will approach 0, this will also approach 0, right? Then b over x approaches 0, same is the case with d over x. So we could write this function as, and x can cancel, right? So we could cancel x and x. So what we really find is that the whole expression here is basically equal to a plus 0 over c plus 0, or a over c, right? So that means that y equals to a over c, is your horizontal asymptote. Is that clear? So I hope these steps are absolutely clear. So we know how to find vertical or horizontal asymptote. Let me sketch this here. All right, let me sketch this here. So we're just making a very general sketch here. So what we'll assume that A is greater than C, right? So we are assuming that A is greater than C. So this value is greater than 1. So we are saying that let this horizontal asymptote be right there. So the value here is y equals to A over C. As far as the vertical asymptote is concerned, we'll assume that D is greater than C, right? So again, it is some negative value, but it's greater than 1. And so we'll say that let this be your vertical asymptote. Correct? Now, this value here will be minus D over C. Perfect. So that becomes your vertical asymptote. You could write this as x equals to minus D over C. Perfect. Now, it's important to find your x and y intercepts. So how do we find x-intercept? To find x-intercept, f of x equals to 0. That means numerator is 0. Ax plus b equals to 0. Solve for x, right? So we have ax equals to minus b. X is equals to minus b by a. Correct? So the value of x will be minus b by a. Now we are assuming, okay, so that is some value. So let's say all these are positive coefficients, right? In that case, what we get here is a negative number. Right? So that becomes your x-intercept. Now, let's also calculate what is y-intercept. So let me highlight this. But I know that you have understood how to find x-intercept, right? Now, let us find y-intercept. Y-intercept is fairly easy. You have to just equate x to 0, right? So if I write x as 0, we get y-intercept y equals to 0 plus b over 0 plus d. So it is b over d. Do you see that? So that becomes your y-intercept. So likewise, we can actually get our intercepts, and we know it is kind of reciprocal of 1 over x graph. So we can actually sketch this graph. Is that clear? Right? So we could really sketch this graph. Now, once you have these values, then depending on these values, you will actually sketch the graph. So let us say we have values with which we get a graph something like this. Let's say, right? So do you see that is a horizontal asymptote, right? And here we get vertical asymptote, kind of like this. Is that clear to you? So what I'm trying to say here is that the y-intercept, this value is b over d, and the x-intercept, this value is minus b over a, correct? So you get a graph like this. So I hope this function is absolutely clear to you. So we may have one vertical asymptote, one horizontal asymptote. We will have for this condition, right? And finding x and y intercepts, we can easily sketch any of these graphs, right? So let's move on and take an example. So here, instead of a, b, c, d, we have some values. Okay, we have two values. So now the question is, find m and n for y equals to 7x minus m over 2 minus nx. So that's the question for you. And what are we given? We are given some condition. We are given that vertical asymptote at x equals to 6. So when I say vertical asymptote at x equals to 6, it means what? It means denominator 2 minus n of x is equal to 0 for x equals to 6. Is that clear? Vertical asymptote at x equals to 6 means if I write x as 6 here, I should get 0 in the denominator. Only then you have a vertical asymptote. So you need to solve this equation, right? So we can say nx equals to 2 for x equals to 6. Is that okay? Substitute x as 6. So we get 6n equals to 2, and we get n equals to 2 over 6 or n equals to 1 over 3. Is that clear? So we get the value of n as 1 over 3. Now, second condition given to us is what? Let's look into this. Now let's look into this condition. X-intercept at 5. Now at X-intercept, y is going to be 0. Perfect. So that is possible when numerator is 0. Is that clear, right? So that means what we have to do now is equate numerator, which is 7x minus m, to 0 for X-intercept at 5, right? So the numerator is 0 when x is equal to 5. Do you understand? So X-intercept is 5 when y is 0. So when y is 0, X-intercept is 5. So when y is 0, we get x value as equal to 5. Do you understand? So X-intercept means a point which is basically 0, 5. 5, 0, right? Y is 0, x is 5. This is what it means. So let's substitute. We have already done 0 for y. Let's put 5 for x. So we get 7 times 5 minus m equals to 0, or m is equals to 7 times 5, which is 35, right? So we get our answer that m is equals to 35 and n is equals to 1 over 3. Is that clear? So that is how you have to look into these rational functions of the form ax plus b over cx plus d. Now we are going to talk about asymptotes in general, right? So we'll talk about asymptotes of rational functions. Let's say r of x is a ratio of p of x over q of x, and we know q of x is not equal to 0. Perfect. So we'll talk about these asymptotes. Now let us say that degree of the numerator p of x is n, and degree of q of x is m, right? So we'll take this condition and then find what we have in different conditions. So let's begin when the degree of denominator, so degree of m means denominator, right? N is the numerator, is it okay? So what I'm saying here is let the degree of p of x, which is numerator. So sometimes I may use this word, and denominator. Correct? So let's take an example where degree of m is higher. Let's say we have x plus 1 over x cubed minus 1. Let me not write minus 1. Minus, let's say, 7. Right? Okay. So let's take this example. Now, in this particular case, we are only discussing different types of asymptotes. So let's consider horizontal asymptote, oblique asymptote, and vertical asymptote, right? Now, we could have either a horizontal or an oblique or none of them, right? So in this particular case, since the degree, and now the degrees here are, we know the degree of m is greater than n. So what we are saying is degree of denominator is higher. In that case, we have a horizontal asymptote, which is y equals to 0. No oblique asymptote. Vertical asymptote is always when the denominator is 0, right? So at x equals to cube root of 7, we'll have vertical asymptote. Perfect. Let's take another example where, so this is case 1, where degree of denominator is higher. Now let's take case 2. In that case, we'll take same degree. Let's say we have 2x minus 3 over 4x. Okay, let's take an odd number, 5x plus 2. Let us say, right? So in this case, what we see is that degree of both numerator and denominator is same. In that case, the horizontal asymptote is ratio of this. So we could write this as y equals to 2 over 5. And when you have horizontal, you do not have oblique asymptote. However, you will have vertical asymptote at we have to equate 5x plus 2 equals to 0. So we get x equals to minus 2 over 5. Is that clear? Let's take another example. And in example 3, I will take a case where degree of numerator is higher. Okay, so let's take x squared plus 5 over, let us say, x plus 1. Is it okay? Now, since that is the case, we do not have horizontal asymptote. In this case, the degree of denominator is lower than the numerator. In fact, what we see here is that numerator degree is denominator plus 1, and that is the case when you have oblique asymptote. How do we find it? We actually do division to find it, right? So in this case, what we will do here is we will divide. So I'm using this space to divide. So let me just divide. So you divide the numerator, which is x squared. Let me write 0x as a spaceholder, and then divide by x plus 1. So it goes x times, we get x squared plus 1, x, right? So we get minus x plus 5, and then minus 1. So it gives you minus x minus 1. Remainder is 6. So y equals to x minus 1. So y equals to x minus 1 is your oblique asymptote. Do you get it? So this is your oblique asymptote. So you get oblique asymptote when degree of numerator is 1 higher. Is that clear to you? Perfect. Now, denominator x equals to minus 1 will give you vertical asymptote. Clear? So these are the conditions when you have oblique and vertical asymptotes. Is that clear to you? Right. So we kind of close on this now, and we'll take one more example. And that is for a special case. We could have a condition like this. Let me push this a bit, just to, Okay, so if we have common factor in numerator and denominator, let's say something like this. If we have x minus 1 times x minus 3. Now what do you notice here? That we have a common factor, x minus 3, x minus 3. So in this case, what we have is we have a whole at x equals to 3. Wherever the factor cancels, this portion gives you a whole, right? However, that portion will still give you a vertical asymptote, and we will have a vertical asymptote at x equals to 1. Perfect. Now their degrees are same, and therefore we'll have a horizontal asymptote y equals to 1 also, right? No oblique asymptote. So that could be another interesting case for you. So what we see here is vertical asymptote is when denominator is 0. So for vertical asymptote, denominator equals to 0. For oblique asymptote, n is equals to m plus 1. For horizontal asymptote, m is either greater than n or m is equal to n. Perfect. So these are the conditions to look into. And for whole, what we have here is common factor. Is it okay? So we have common factor for whole. Is that clear? So I think that summarizes almost everything about asymptotes and wholes, rather discontinuities for rational functions. Now let's take up the next topic. Now with the help of a graph, we'll summarize all our learning. We need to graph y equals to 2x plus 6 divided by x minus 2. So I'll sketch a rough graph here, and we'll actually calculate all the values. So the function is y equals to 2x plus 6 over x minus 2. We could also write this as y equals to, taking 2 as a common factor, we get x plus 3 divided by x minus 2, right? So we could use either one of these equations. So let's begin with vertical asymptote, correct? Vertical asymptote means denominator x minus 2 equals to 0. So that gives you vertical asymptote at x equals to 2. So at x equals to 2, let me make a vertical asymptote. So this is my vertical asymptote at x equals to 2. Is that clear, right? So this is x equals to 2 for me. So this point on the x-axis is 2. Now let's also calculate horizontal asymptote. Since the degrees are same, right? So the horizontal asymptote is 2 over 1, right? So horizontal asymptote is y equals to 2. So y equals to 2 is the horizontal asymptote, which we got from here, right? This is 1, correct? So let's say this is my horizontal asymptote. Y equals to 2. Now we need just x and y intercepts. So let's write down X-Intercept. X-Intercept is when y equals to 0. That means numerator is 0, right? That means 2x minus 6 equals to 0, or x is equals to 6 over 2, which is 3, as you can see from this particular equation, right? So we have X-Intercept at 3, so let's put this X-Intercept here at 3. Does make sense to you, right? So let's call this 3. Now let's find the Y-Intercept. Y-Intercept is when x equals to 0. Substitute x equals to 0. You get y equals to 2 times 0 plus 6 over 0 minus 2. Or we get 6 over minus 2, which is indeed minus 3. So we get the y-intercept as negative 3. So negative 3 will be somewhere here. Let's call this negative 3. Now, a mistake here. It was 2x plus 6. I'm sorry. I wrote minus here. So this is plus 6. It will go this side. This is also negative 3. So this was the wrong point. I should have written minus 3. Is that okay? 2x plus 3, right? So the numerator is 0 for x equals to minus 3. Correct? So I copied it wrong. That was a problem. So we get x-intercept at minus 3. Now we can just connect these points and draw. Now this side is very clean. We just do it like this. And here we do have kind of like this. Do you see that? And these graphs are actually symmetric about that point. So I don't have space to get further down there, but still you could actually sketch, right? So sorry for this mistake. It was plus 3. I copied it minus. Perfect. So the x-intercept is minus 3. Okay. Now, to get some more points, what you should do here is that you should find the value of the function at, let us say, x equals to 4, right? So we'll say when x equals to 4, that means a point somewhere here, substitute 4 and find y. So we get 2 times 4 plus 6 over 4 minus 2. And that gives you 8 plus 6, which is 14, over 4 minus 2 is 2. So we get 7, right? So let us say this point here at 4 gives you a result here at 7, right? Let's say this is 7, okay? So you can get fairly accurate graph as shown here. So I hope the steps are absolutely clear to you. Here we did a mistake while copying the question. So it was 2x plus 6. I wrote minus. So you actually get x equals to minus 3 as your x-intercept. So let me write down x equals to minus 3. That is the point. And once you have x and y intercepts, you just connect them. You get one side of the graph. The other side, get extra points. Correct? So calculate value at 4 or 5. Is it okay? And get some more points. So I hope that is clear. Let's move on and take the next example. Now let us see how to solve equations involving rational functions. So we have this equation which is 2x over x minus 12 equals to minus 2 over x plus 3. Now to solve such equations, what we can do is we can just cross multiply. So whenever we are working with equations, you can cross multiply in such cases, right? What I'm trying to say is when you cross multiply, you get 2x times x plus 3 equals to minus 2 times x minus 12, right? Then you get a linear equation and then solve it. I mean a quadratic equation in this case. So when you open the bracket, you get 2x squared plus 6x equals to minus 2x plus 24. Bring all the terms together. So get 2x squared plus 6x, let me write, and plus 2x minus 24 equals to 0. Combine the like terms. You get 2x squared plus 6 plus 2 is 8x minus 24 equals to 0. Now you factor. 2 is common, so we get x squared plus 4x minus 12 equals to 0. And now what you can do is 12 is the product, sum is 4, so 6 times 2. So you could write this as 2 times x plus 6 minus 2, right? Bigger number has to be positive in this case. So that gives you two solutions, correct? So let me write down on the right side final equation, which is equivalent to 2 times x plus 6 times x minus 2 equals to 0. Now whenever you're working with rational equations, you should write your restrictions also. So in this particular case, remember x is not equal to what? Not equal to 12 and not equal to minus 3. So in our equation, we don't get those answers, so that is fine. What we get here is x equals to minus 6, which will make this 0, and x equals to 2, right? So that is our answer. Is it okay? So that is how you're going to solve it. Now some of you can have alternate method. So let me show you that also, alternate method. Like we solve inequality. So we are given 2x over x minus 12. Bring this to the left side, so we get plus 2 over x plus 3 equals to 0. Now you take common denominator of x minus 12 times x plus 3, and then you could write this as 2x times x plus 3 plus 2 times x minus 12 equals to 0, correct? You can factor out 2, and you can factor 2 out, and what you get here is that x times x plus 3 plus x minus 12 equals to 0, because the denominator cannot be 0, right? And when you solve this, you get the same solution as 2 times x plus 6 times x minus 2. You know, open the bracket and solve. So once you do that, you get the same answer. Is that okay? So you get x equals to minus 6 and x equals to 2 as your answer. So this could be the alternate method, right? So factor. After this, you factor and solve to get your answer. Is that clear? So that is how you're going to solve equations related to rational functions. Remember to write down restrictions and also check your answers, right? So note here is check solution. Is that clear? In our case, since it is not one of those restrictions, we know it's the right answer. Is it okay? Let's move on and do inequalities now. So the inequality which we'll work with is 55 over x plus 16 greater than minus x. So in this case, never cross multiply, right? Never cross multiply. You have to bring them to same side. Then solve. Do you understand? That is critical, right? So these are two things to remember. So we'll bring them to same side. So we get 55 over x plus 16 plus x is greater than 0. Take common denominator x plus 16 and you get 55 plus x times x plus 16 greater than 0. Open the bracket. So you get 55 plus x squared plus 16x over x plus 16 is greater than 0. Now you have to factor the numerator, right? So now you factor the mistake, right? We have x squared plus 16x plus 55. Now, yeah, I was going to do a mistake. So the numerator should be this. We'll arrange it. We'll factor it. And denominator is x plus 16. And we want that to be greater than 0. So here we have to find two numbers whose product is 55 and the sum of these two numbers is 16. Well, 5 times 11 we know works. Correct? So push it leftwise, yeah. So 5 times 11 works, and therefore we could write this as x plus 5 times x plus 11 divided by, we have a factor x plus 16 greater than 0. Now we have two zeros and x cannot be equal to 16. Let's write down the condition x is not equal to minus 16, right? So we have 3. So we'll now make a table to test it out, correct? That's the whole idea. So, and we'll check each interval. So there are 3 points which will divide it into 4 intervals. Is it okay? So let me make this like here. Okay. So what we have here is one is at x equals to minus 16. So this is x equals to minus 16. So I'm making a circle here. You cannot have this point. It is a vertical asymptote. And then we have at minus 5 and minus 11. So this is minus 11, this is minus 5. So these are 3 points to consider. So in each interval, let's take a test point. So test point here could be, let's say, minus 20. Here we could take as minus 15. And here we could take as minus 10. And let's take 0 here. So the 3 factors are, let me write them in orders: x plus 16, x plus 11, and x plus 5. Now if I use minus 20, in that case, what do I get? This is negative. Minus 15, these are positive, right? For 11, both these are negative and these are positive. For 5, we get this negative and this negative. Only when I put 0, you get a positive number. Now, this rational function, when you multiply 3 negatives, you do get a positive. When you multiply 3 negatives, you get a negative, right? When you multiply 2 negatives, you get a positive. 1 negative is negative. All positives is this. So what we see here is that we need something positive, right? So we need positive to be our answer. So it is these 2 intervals. Is it okay? These are negative. And so we get our solution as within these intervals. Is that okay? Within these intervals. So we get our answer as x is greater than 16 and less than 11, minus 16 I mean, and less than minus 11, or union we say, x is greater than 0. So that becomes our answer. Is it okay? So that is how we solve our questions. Correct? So I hope the steps are absolutely clear. The idea is bring them together, factor, and then find the intervals where you have to check whether the function is positive or negative. Once you get your answer with the help of a table shown, you can write down the value. So what we get here is either we could write in this form also, minus 16 to minus 11 union 0 to infinity. Is that okay? So that could be another way of writing the same solution. So go through these steps once again. Try to understand how to solve rational inequality for simple functions as shown here. Let's move on and take up the next question. So we are almost at the end. This is the last question to solve. I hope you understand and appreciate what I've done here to review rational functions. Now we need to find equation from the given graph. As you see, this is a very typical graph of rational function where things are very different. We do not have any vertical asymptote. So no vertical asymptote. Do you see that? So these are very special cases. And domain has no restrictions. So what is the domain here? Domain is x belongs to real numbers, right? So that is the domain. And what is the range in this particular case? Range is that y belongs to real numbers. However, y is greater than 0. It is never equal to 0, but it is less than equal to a value, which is 4 in this case. So this value is given to us as 4. So that is the function for you, right? You can write more characteristics about this function. Most of your functions were either increasing or decreasing. Here we have a turning point. The function is increasing and then decreasing. So it's a very typical function. But the equation is the main issue. How do we get equation of this function? So let's look into this. So we could always say y is equal to something which we don't know. Let's put a here. However, since we know that denominator is not negative, there is no vertical asymptote, right? So that means we know denominator is always non-zero. I should say always positive, right? Or I should say non-zero, right? Non-zero. So that is possible if I have equation like x squared plus 1. Do you see that? It's like a parabola which has no x-intercepts. So that is a function whose reciprocal we are trying to figure out. Is that okay? So that is the function. So if you see a graph like this, that is your general equation. How do we find the value of a? We know y-intercept, right? So use Y-intercept. So we have Y-intercept, which is at 0, the value is 4. So let's substitute this value in this equation. So we get 4 equals to a over 0 plus 1. So when you cross multiply, you get a equals to 4. Perfect. So you get a equals to 4. Substitute a equals to 4 here. So what do you get? You get 4 over x squared plus 1. Correct? And therefore, we get our equation, which is y equals to 4 over x squared plus 1. Is that correct? That is how you can get equation of such a graph. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that would be great. And also, don't forget to post your test papers so that we can share it with others. Thanks for watching and all the best.